In this problem, we're being asked to evaluate an integral. It's the integral of a rational function, and on this one it's fairly complicated looking, but which might push you towards a substitution. But if you try that, you'll find that substitution doesn't go well on this. You may be able to rewrite this integral with some substitution, but it's difficult then to write it into a simpler form than this one. The better idea is to use a little bit of algebra on this to simplify the look down. What I'm going to do is break this fraction into three pieces. I've got a common denominator here, and I can break this into the sum then of three fractions: x cubed over x, 2x squared over x, and minus 1 over x. And if I look at each of these pieces, the antiderivative technique here is quite a bit simpler. The 1 over x will simply be a natural log of the absolute value of x, and these other two can be reduced, these fractions. So I will simplify each of those. There's an x squared, x cubed over x, there'd be just an x squared left. Here the 2 would remain and one of the x's would be canceled. And I can now anti-differentiate this. The function whose derivative is x squared would be 1/3 x to the third. And if I pull this 2 out of the way, the antiderivative of x would be a 1/2 x squared. And the antiderivative of 1 over x is the natural log of the absolute value of x. And then we don't want to forget to add on our arbitrary constant. Then I'll take one more pass through here to clean this up. These fractions, now the 2 and the 1/2 combine to be a 1. So it looks like I've just got this. And it's always a good idea on these to check your answer. It's fairly simple to check. Well, you need to remember to add the plus c, but if you differentiate your answer, you should get the original integrand back. It might take some algebra to do that, but it's worth your while, because if there was a mistake, I would not only detect that, but there's a good chance that I would find the mistake itself. For example, if I messed up the 1/2 here, I would have a coefficient that's wrong on this x squared, and when I differentiate, then I would get something that didn't look right up here with the 2x squared, and that would indicate that my mistake might be right back in this area, that sort of thing. If I differentiate this, the derivative of x cubed is a 3x squared, so 1/3 times 3x squared will be an x squared. Derivative of x squared is 2x, and the derivative of natural log of the absolute value of x is 1 over